Okay, we're now ready to start talking about combination circuits, okay, where you've been given resistors that are connected in series, parallel, and all possible things. So we ask a bunch of questions there. Of course, we want to know what the effective resistance is. We can ask what is the effective resistance for this circuit. We can also ask, to rate the power. Okay, rate power in increasing order, and we then basically can ask current and all those things. So in order to answer the second question of rate the power in increasing order, we need to basically find all the things. We need to know the current and the voltage and all kinds of stuff. So let's go ahead, let's do this, and let's figure this out. Okay, now before even starting the circuit, if you just look at the circuit, the question is, can you figure out, can you tell which one is going to get the most power? Alright, and the answer to that is actually, you really do not know this. Okay, if all the resistors were the same, you would have an idea. Okay, but in this case, clearly they're all different values, so you don't really know. So the best thing to do here is to just calculate and let your calculations simply just tell you what, how to rate them. So what we'll do is, again, we ask the question here, are there any simple series or parallel parts in the circuit? Okay, if you look at it very closely, you see that the 40 is not in series with the 150 or in series with the 100. So, so the 40 is out of the question. So in circuits like that, it's always best to start farthest away from the voltage source. And if you look at it closely, what you'll notice is that the 150 and the 100 are in parallel. So what we know is that the 150 ohm is in parallel with the 100 ohm resistor. Okay, now since these two are in parallel, now we can figure out the effective resistance. And what we know is that 1 over, I'm just going to call it R1, is going to be equal to 1 over 100 plus 1 over 150. Okay, do the basic arithmetic here, find the LCM, and what you'll end up getting is this will be equal to 1 over 60. So this gives me R1 is equal to 60 ohms. Great. What I'm going to do is redraw this circuit where I have my voltage source, my 25 volts, I have my 40 ohms, and now I'm going to replace that parallel combination with this 60 ohm resistor. What I like to do is put a little circle around this just to remind me that the 60 ohm was originally made up of something else. Okay, now if you look at the circuit, when I, clearly the 40 and the 60 are in series, so we know that 40 ohms is in series with the 60 ohm. Okay, so this allows us to obtain the following thing. We know R effective is going to be equal to 40 plus 60, which happens to be 100 ohms. Great, we have this. Okay, so now I can simplify my circuit, and now I have 100 ohm here, and I have 25 volts, and once again I'll put a little circle just to remind me this 100 was not by itself. So now in order to find the power and the current and all those things, what we're going to do is go back, okay, go in reverse. So the first thing we'll do is we'll figure out all the stuff for this circuit, okay, this circuit that I have in front of us, 25 volts and 100 ohms. So clearly this is what the missing variable is, the current. So we know that the current is going to be equal to 25 over 100, and this is equal to 0.25 amps. Awesome. So now we know everything for this circuit. We know the current, we know the voltage. Okay, we could find the power, but we really don't need to do that. Now what I'm going to do is draw the circuit just before it. And if you look back, you will see that we had a 40 ohm, okay, and a 60 ohm connected in series. So here we have 25 volts. We know the current is equal to 0.25 amps. So this tells us that since the two resistors, the 40 and the 60, are in series, okay, so since the 40 ohm is in series with the 60 ohm, this is just my own notation, just for short form, okay, we know that the current through the 40 is equal to the current through the 60, and that happens to be equal to 0.25 amps. Awesome. So we know this. Now that we have this, okay, we can find the voltage across the 4D by using Ohm's law, which is going to be equal to simply the current 0.25 multiplied by 40, okay, and that'll end up being equal to 10 volts. And similarly, delta V 60 will end up being equal to 15 volts. Okay, you can do 0.25 multiplied by 60, that'll give you 15 volts. Great. So now we have found everything for this circuit. Okay, so we know delta V40, delta V60. Now if you look at the 40 ohm, the 40 ohm was originally by itself. So now we've exhausted everything for the 40 ohm. We know its current, we know its voltage. Okay, the 60 ohm on the other hand, it was originally made up of two resistors in parallel. So the 60 ohm, okay, is the same as the 100 ohm and the 150 ohm in parallel with each other. Okay, and since they are in parallel, we ask the question, what is it that they have in common? All right, the answer is parallel resistors have the same voltage. So whatever voltage the 60 got is what these guys are going to get. So it's going to be 15 volts. All right, so this tells us that delta V100 equals 15 volts and that delta V150 is equal to 15 volts. Now that we know the voltages for each one of them, we can find the current. So you can do I100 is equal to 15 over 100, which is 0.15 amps. And then similarly, I150 is going to be equal to 15 over 150, which is 0.1 amps. If you add them up, you end up getting 0.25 amps, which is the total current in the circuit. Great. Now we have everything. Okay, so for the 40 ohm resistor, okay, we have the current, we have the voltage, and now we'll also find the power. Okay, so for the 40 ohm, the current is 0.25 amps, the voltage was 10 volts, and the power is simply I times delta V, so it's 0.25 times 10, which happens to be equal to 2.5 watts. Okay, for the 100 ohm, the current is 0.15 amps. Okay, the voltage is 15 volts. Okay, and the power is once again I times delta V, so 0.15 times 15, which will end up being equal to 2.25 watts. And for the 150 ohm, okay, the current was 0.1 amp, the voltage was 15 volts, and the power once again is I times delta V, which is 0.1 times 15, which is 1.5 watts. So now we see that the power of the 150 was the least. Okay, then we had the power of the 100, and then we had the power of the 2.5. So or rather the 40. Now clearly, you know, these are all these things will depend on the actual values of the resistors. There is no one such rule. So the only way you can make any conclusions is by actually doing all the calculations and coming up with the results. All right. So check this out again. Is make sure you understand all the parts in this circuit. Okay, there are lots of little things that you must go right. You must remember your properties of the circuits, and if you keep track of all the stuff carefully, you will end up coming with the correct results. All right, that's it for this one.